So I'll talk about Neural open product frameworks and the three pillars on which it is based out of. Like one part is the disaggregation of hardware and software. Second part is the software is completely built using open source, and the curation, the third principle, is the enhancement we have done to make the software carrier grade, which can be used in telecom or like cloud providers network infrastructure. A little bit of background about me as we start. I have around 2 decades of experience in the telecom and datacom industry. Co-founded 3 startups. So Pixel was my first startup, which focused on content management space. It also used a lot of open source to build that product. Then eTrans Network, which was a telecom consulting company, using which we have actually deployed we have actually done around 40 projects across the globe with operators in Middle East, Southeast Asia, even in India, and also with cloud operators. Overall, I think we have worked in 5 countries outside India, including US, Australia, Middle East, Southeast Asia. And lastly, recently is neural networks, which I would say a lot of the experience that we gained in eTrans comes into neural. And that's why I think explaining about that is very key, so that you get more insight why open source is a good way of looking into building products that to carrier grade. That was the insight that I got while working as part of eTrans, working with multiple operators globally and their use of open source. I had also been part of the initial engineering team of Apigee. Well, it's quite some time back, and it got acquired by Google, I think 5 years ago. Before that, I worked with companies like Cisco, Huawei, and Motorola. Again, if you see, all of them are dealing with telecom or datacom as architecture, as an architect or part of their city office team. Now, predominantly, while working with the second startup that I actually co-founded, which is eTrans Network, I have worked with multiple operators, telecom as well as cloud operators across globally. I mean, mainly Asia, but also in US. So while working with them, what we figured out is that a lot of these operators were taking our help to build carrier grade software, which they are using to actually use within their network. Like if you talk about like any telecom operators, like let's say in India, like you have Airtel, you have Jio. So what they do is that they buy networking solution from vendors, traditional OEMs. Like if it is radio related, they buy it from probably Samsung or Nokia or Ericsson. If it is the wireline, probably they buy Cisco or Huawei or similar kinds. Huawei, of course, in the radio side also. They buy equipment from these companies, build their entire network infrastructure, and then we as retail customers to Airtel or Jio, we pay them for the network connectivity and all the other solutions they provide. Now, thing is that lot of operators found that while going in that model, they were being pretty much controlled by vendor. And that's the reason lot of the operators I worked earlier, like as part of eTrans, started building their own products in-house. So they were trying to build a router like what Cisco builds, or maybe a P gateway like what like probably a Ericsson or a Huawei builds P gateway, which is used as a packet core network within a 4G. So they were trying to build themselves and then use it within their network. The reason they were doing that is that they were completely controlled, and they were very much dependent on the vendors, and they wanted to come out of that. In 2008, 17, and I think AT&T in their blog wrote that vendor lock-in, this particular thing where you are pretty much tied up with vendor, is called vendor lock-in, is making their upgrades slower, increasing their cost, and also hampering their innovation. That was written by AT&T CTO. And the blog is still available. You guys can look into that. And what they propose is that they are going to, in their 5G network, which they're going to upgrade, they are trying to build their open disaggregated networking solution, which contains open software from another vendor and hardware which is from another ODM, similar to like off-the-shelf hardware available like Dell, similar kind of off-the-shelf hardware which is carrier grade, like uses Broadcom chipset or like Mellanox. So they will integrate both the hardware and software and then put in their new 5G network. They won't use the traditional OEMs to ensure that they are able to innovate. So if you see, the same thing actually happened with the customers that we were working. We didn't work with AT&T, but we were working with similar telcos like AT&T or cloud providers like AT&T. And we helped them to build such solutions. And these solutions are live in the network now and supporting millions of customers. And that's when I got the idea about Niral. Like that's in like 2018 and 2019, we started Niral to ensure that we build solutions which are non-traditional using open source, which are open and disaggregated. Like you can use any kind of hardware on top of that and build a solution which can be used by operators. When I talk operator, it means like telecom operators or cloud operators, or it can be the internet service providers. Any queries, do feel free to ask, or I'll kind of move ahead. I think I missed one point, and I should definitely thank Google, Facebook, and Amazon, because a lot of my initial thoughts on Niral was based on that. Like I have talked about the problem, which you see is in the left, which are the traditional, when you use traditional network infrastructure, which causes vendor lock-in. But there is also another method of looking into that, or the other side of that. Google, I mean, if you see Google, Netflix, Facebook, or Amazon, they are maybe a application or application infrastructure or platforms company, but inherently within the back end in their cloud, they use a lot of network infrastructure. And surprisingly, if you see, most of their network is actually using such disaggregated and open solutions that I was mentioning. So even their network played a critical role for us to actually start Niral. And like this is from Light Reading, and a survey done in 2018. You can find it in Light Reading. So what you see is that, because I mean clouds generally they use data center switches. Their infrastructure is not very radio centric or like transport centric, but they are like high throughput within the network data center Ethernet switches, right? So in 2018, in the data center market, out of like 100%, like you can see that around maybe 20 to 23% of the switches which are sold was open switches, like as I was telling, Dell, open hardware, open. You can put any software on top of that hardware, in fact, and it is using some open design which are actually driven by a community called Open Compute, OCP. So so in around 23% of those data center switches were using such open hardware sold in 2018. And not surprisingly to me, more than 2/3 of that was actually the customer was Amazon and Google and Facebook. So what Amazon and Google and Facebook are doing is that they are not going with traditional network infrastructure, but they were buying such open hardware from the market, and on top of them they were either putting their own software because they have a huge R&D team, so they can build such network infrastructure on their own, or they were working with partners like us, Niral, to develop such operating system and develop their own disaggregated open network. So that is in 2018. I'm sure if you look into 2020, this would have gone way ahead of 23%. Maybe now it may be around 30% and may also increasing with time. So I mean, this also, I mean, what the study or analysis that we did for Google and Facebook also played a critical role on starting Neural and the open networking infrastructure operating system that we have built. Yeah, a lot of market trends on that direction. I mean, of course, all of us are aware about Red Hat buying IBM, but which you guys may not be aware because all these are kind of recent, but all of them are on the same direction about open disaggregation of network. Is that there is a company, I mean, all these Metaswitch, Cumulus, and DriveNet, all these three companies are our competitors. They also make NOS, network operating system, like us, but I think we are the only one which is open source based. They are not completely open source based. So for me, I mean, traditional network is the first generation, I mean, or like the earlier generation network, and the binary NOS providers are the second generation. And open source, like what Metaswitch or Cumulus provide is a binary NOS on open hardware. This I call the second generation of network disaggregation. So when Metaswitch or Cumulus or DriveNets are playing. And what I think about Neural is a third generation where even the software is no more binary. There is no vendor control even in that point. It is totally open. It's open source based solution, and we actually share the source code with the customer so that they can build on top of that, similar to kind of Red Hat. So we think the Red Hat model is the right model, and the next third generation of network disaggregation would be open hardware with open source. And I think Neural is probably one of the only, or maybe the only company playing on that as a network NOS at this point globally. So coming back to the other companies that I was mentioning, so Metaswitch, one of our competitor, and like they provide the NOS, binary NOS. They got acquired by Microsoft in May of this year, and mainly to empower the new generation of disaggregated network, which will have edge cloud or like telco clouds, which are a inherent requirement for 5G. Similarly, almost just two weeks before that, like in May of 4th, 2020, Cumulus, another data center NOS provider, competitor for us, and I would say they are also our partners. We work together to develop the open source FRR routing, where Cumulus I mean, they are a major contributor, and we are also a contributor to the FRR community. So they got acquired by NVIDIA again for bolstering their networking, basically open disaggregated networking for data center. I think again moving towards edge cloud. And of late, recently, I mean last week. One of our third competitor called DriveNet, which is based out of Israel, recently announced last week that AT&T is going to deploy their next generation network cloud, which is for 5G. And AT&T is not taking any traditional vendors, but using DriveNet for their 5G core, which is a major milestone, I think. And I have to thank, I mean, DriveNet for getting that. I mean, that is probably one of the biggest milestone for the NOS community, open NOS community. And why is it happening now? I mean, so I think for the network infrastructure disruption, this is the right time, because firstly, there are multiple white box solutions available, white box hardware. Like you get a hardware which is 60 gbps gbps. You get a hardware which is 4.6 terabit using white box solution based out of Broadcom, Marble, Mellanox, Barefoot, NXP. So NXP can you get white box which are even in the 4 gbps range. So you can start from 1 gbps, go to 4.6 terabit using such white box. The options are huge. And there are open hardware community like OCP, Open Compute, where they actually take the open design and like they actually accept whether it is basically they go through that and see whether it is acceptable to make carrier grade hardware. So so availability of white box options, definitely now um, there are a lot of options available. So this has SDN and NFB has been there for some time, but now it's getting matured with, you might have heard about ORAN in 5G and all those things. So there are real use cases now for SDN, NFV, network network slicing, traffic engineering, all those would be driven by SDN and NFV. Then maturity of open source solutions. Uh, you would be surprised, like while working as part of eTrans in my previous company, we most of the solutions which we developed and which are live in the network also use a lot of open source, and telcos actually use a lot of open source. And similarly, even a lot of the traditional OEMs build on top of open source solution. So and they also contribute to open source solution. Like we work with we work with multiple open source community, and our along with us the contributors include AT&T, Orange, VMware, Microsoft, Cisco, etc. So the community is getting much more mature now. It is pretty matured. And the Danos, I mentioned AT&T is actually planning to use a lot of open source in their 5G. In my, I think the first slide I mentioned, or the second slide, they are actually using open source in their network, their live network. Now, industry acceptance of open source, yeah, of course, that is important. A lot of communities like the telecom infra project has come up. ORAN has come up. ORAN focuses more on the RAN part to initially start with. How you disaggregate the RAN, make it open, like using like RU, CU, and DU, which are more on the cloud. The radio stack processing being done on the cloud, and only the DS or the very specific hardware processing is done on the cell tower, which is the RU, the radio unit. After that, using eCPRI, the packets are sent towards the cloud for doing the processing on the cloud. Similarly, TIP is another community, and we are part of TIP. We are one of the globally, we are one of the NOS vendors in TIP. So TIP has actually lot of trials have gone, and a lot of deployments are going on, which are facilitated or front-ended by TIP with a lot of vendors who are our competitors. We work together. So the good thing about open community is that all the competitors are also working together in unison to actually ensure that the open community grows. So, and lastly, and also I think this is a major important thing, is that 5G and growth of 5G and mobile edge compute. So this is probably the right time for open disaggregated networking and move towards open source also. So these are some of the key drivers for this. Coming back to Niral and the products and how we use open source, which that's probably the second part which I'll cover. So the vision and mission of Niral is to work and partner with operators, which includes telecom, for 4G or 5G, for internet service providers who want fiber, providing fiber to your home. Then cloud operators who provide, like it can be similar to Amazon AWS, who are trying to build similar to AWS or Google GCP, or building their own enterprise data centers. We want to partner with them and help them to move from being vendor controlled to become vendor agnostic by embracing like curated open source and disaggregated product framework. So what we do is that we work with them, we enable them to buy the hardware of their choice. On top of that, we put our open network operating system to provide the platform on which you can build we can run applications which can be used for cloud or like um, the the telecom, right? Um, Also, as part of 5G, there is lot of we talk about network disaggregation, but there is lot of aggregation also happening. By aggregation I mean lot of like separate components in the network, especially in 5G. When I show you the network of 5G are coming together and being going towards the cloud. So that's what we call web scale. So instead of having so many separate components, we kind of integrate them to make a small micro cloud or edge cloud. On top of them, you can have a server farm on which you can run microservices and having a virtual function, like maybe virtual function for the, for a P gateway, or a virtual function for a MME, or a VoIP solution, or a CDN solution can run on these micro clouds, especially for 5G, where latency is a key important thing of consideration. This is the future of network, and the previous one was more of traditional. And as part of Niral, we are not only looking at the open source disaggregation, but we are also looking at web scale network operating system. This is the network I was talking about, which is very true for 5G, but it is also pertinent for the cloud, because I mean, what you see on the right hand side here is something which is very similar to a cloud. And what you see on the left hand side is access specific. So it can be like for 4G, 5G, it can be for your fiber to your home, or it can be also DSL or cable modems coming to them. So here you can see the network for, but especially if you take a telecom network, it's pretty complex, right? You have the radio unit sitting here, then you have the front haul gateway, which is kind of defined in ORAN at this point. You have the DCSG defined in TIP. These are kind of like routing and transport equipment to take the packet towards the core and or towards the internet. So we are providing a network operating system which is which would cater to this entire ecosystem. We are not focusing on all these things as part of Niral at this point, but initially we are focusing on some pockets of the network. Like we are focusing more on the access part, which probably has the DCSG, the front haul gateway, or the edge cloud, 5G edge cloud, which comprises of like the DPI, deep packet inspection, which is used like application based firewall, or the UPF. But in future, we would like to focus on the entire ecosystem, the entire network, using our open source network operating system. But at this point, yeah, we are focusing on the edge cloud and the 5G access component. So what are the three steps? These are the three main steps, which I think I've been repeated earlier also, to really build NiralOS. First thing is the disaggregation of hardware and software, which is kind of blessed by the hardwares which are accepted by the open compute community, is the hardware we work with. We work with a lot of partners who make such hardware, open hardware, like H-Core, Alpha, Delta, UFI Space, which are mainly for like unit throughput of like 4 Gbps, sorry, terabit or so. or like it's starting from like 60 Gbps to 4 terabit. You have hardware available on this range. Then if you need more compute centric, then we use Dell. Like for DPI we can use Dell. For gateway purpose, which are more routing centric, you can use like 4.8 terabits from H-Core or like from other companies. Whereas if you need for a home gateway, like which can be used to for SD-WAN, for a SMB kind of market, which you need a 2 or 3 Gbps, you can use a Acton kind of box which runs an NXP chipset, provides you that kind of. So you have lot of options available. I've just shown some of that. That is the disaggregation part. Now the important thing, or probably more important for this which is the OSI summit, open source summit, is the open source part. So we are a contributor to Danos, which was seeded by AT&T, and we have done quite a bit of contribution to this. So to build our network operating system, our network operating system uses Danos. It uses FRR routing, which has been contributed by Cumulus Network, which is one of our like competitor. Plus we work together. That's the interesting part. But we also have some of our partners who are on the carrier, like Orange. We are also looking, means though they are we are working as partners. So you can see we have competitors, we have customers who are our partners in the open source community. We work with ODL for the SDN controller. Similarly, for building a DPI solution, we use NTOP and Nginx. For IoT, use IoT Ajax Gateway. And so our solution of NiralOS has to also be carrier grade, right? We need to ensure that all the it has to be interoperable with the traditional networking equipment, let's say like Huawei or Cisco or like Ericsson. So we have to build on top of that whatever is missing. So that's the curation part. So we build on top of that. So our network operating system is 70% of open source and 30% which we have built, our curation. And part of that curation we have contributed back to the open source community. And whichever we could not contribute because of restrictions or because of some other dependency, like where we work with hardware, the SDK cannot be like the integration that we do is the SDK, maybe one of the hardware chipset, we cannot really open source that because that is not, we have an NDA which doesn't allow us to do that. So those things are not open source. Otherwise, most of the things we try to contribute back to the society. So we have a lot of contribution. We are a maintainer in FRR routing, and also one of the initial contributor to Danos, and with the other open source also we are working. So and we also share our source code with the vendor, with the customers, because while working, as I mentioned, eTrans in my previous company, what I saw was that the operators want to build on top of that. Most of the operators now have a R&D team. They have their own R&D team. So we can collaborate with them to build better solutions, which they need. Suppose if I give them only the binary, they won't be able to build on top of that. They won't be able to do new features. So the open source, as well as sharing the open source to the customer, especially for operators, be it cloud, telecom, or ISP, is very important to go to the next generation of disaggregation, where Niral plays a role, I mean, as an open source and open hardware network disaggregation. So I think that is very important, and we definitely work on that. We definitely the idea is to provide our own sources to the operators, and that's what is NiralOS at a nutshell: curated open source disaggregated product framework. We provide the support as like how Red Hat does. We have an annual subscription for that. We try to be zero capex. Of course, the hardware has to be directly bought for the but for the NOS, network operating system, we want to work similar to Red Hat. No capex, it's opex based. I've covered this, so I'll move quickly in the interest of time. Yeah, this slide may be important, so I'll spend some time on this. As part of our research, the 5G diagram I showed you, lot of things can be done using open source. Lot of the components can be built using open source. We are, and as I mentioned, our vision as we grow, we would like to focus on most of the things as a network operating system provider using open source for most of the components. At this point, we are focusing more on the router switch and part of the edge cloud for 5G, like for example, the DPI, the CDN, and the IoT gateway, and of course the SDN controller. So these are some of the key focus areas for us where we have customer traction. We are doing trials with customers in India, in Asia, and also globally. So we are working with them, but definitely we would like to see, in some cases, I would also like to mention that we are working with some partners who focus more on the radio bus to create some solution which is like wireline plus wireless. But definitely there is like guys who want to focus on wireless. I think there are a lot of open source available, who at least on top of which you can build. Um, so uh, some of the key milestone for us is that we are one of the NOS provider globally in tip for 5G as well as 4G. We are a global NOS vendor along with multiple others, and we are not a NOS vendor like unlike others. We focus on 5G access as well as the edge. We are focusing on the edge cloud also. Um, Next, like for some of the contribution that we have done to AT&T for Danos, which are seed coded by AT&T. In fact, they have written in the latest release note, there's a lot of acknowledgement about Niral, and they have thanked our contribution. AT&T has thanked our contribution to the open source community and to build Danos as a operating system for for the networks. As part of a NESCOM report, we are reported as one of the key 5G technology vendors from India, along with some of the other players like VVDN and Tejas. You can get the report. Yeah, so again, probably reiterating what I mentioned, we are focusing on the telco and the ISP edge access. Edge access is like the DCSG and the fronthaul gateway and the access router. Again, using open source that I mentioned earlier. On the edge part, we are focusing on the DPI, the CDN, and the UPF, which are the same NOS working as a container-based solution, microservice run through a Kubernetes, which can be spawned in. You can spawn new virtual functions. Basically to create like DPI, UPF, and these solutions are mainly on the 100 gig stuff, and these are like in the access thing can go up to 4.8 terabits because these are pretty high throughput. Whereas these are generally x86 based, the telco cloud part, so they are generally on the 100 gig range. Then you have the data center, which I was mentioning. Interconnect between inter-data center interconnect. You can have a 4.3 or a 3.2 terabit interconnect between data center using optical transport. We have a solution here using white box. Then you can do intra-data center using VXLAN, EVPN. For that also we have a solution. So yeah, these are the three focus for us. Now coming to the product per se, a couple of products that I'm mentioning here using open source. One is the DCSG, which is disaggregated cell site gateway, pretty much being used in 4G, 5G, as well as a part of that is you can say is using in data center as well as edge cloud too. In data center and edge cloud, you use a lower version of the same But when you use in 5G, you are using a like a defined Broadcom version, which is like 4.8 terabit, goes up to that. Whereas when you use in the data center, you can use like 100 gig to, or like that kind of throughput based on your requirement. Um, so we support most of the features which are available by the traditional OEMs, and some of them are there in the network, our roadmap. So because we are part of the community, we actually support like segment routing and even some of the other stuff here. Uh, so regarding the hardware, again, if you see there, H core, UV space, Acton, and we can work on any kind of hardware like x86 or wide Broadcom NXP, or like any other kind of chipset based. And we also have the SDN controller integration, which is based on the ODL, whereas this DCSG NOS is based out of Danos and FRR. These are some of the hardware used, starting from 60 Gbps going to like 4.8 terabit. Now coming to the DPI, which is used as an application firewall, which you can put in a data center or in the 5G cloud for policy enforcement. Like whenever, like in Middle East, if you go, right, if you want to do a voice call using your WhatsApp, you will see that the VoIP is getting blocked. You cannot do an international VoIP call. Yeah. So this is blocked because there is an application-based firewall. Like they won't allow you to do video call over IP, which are international, in the packet core, in the cloud of the telecom network. So we have such solution built using open source, using solutions like NTOP, PMSense, and of course for the networking, the DPTK is integrated. So we work with Dell, we Supermicro, and for very small deployment like SD-WAN, it can be used in Acton too. So these are some of the blocks used for that, and for managing them, centrally use ODL. So we provide the PCF functionality, then the shaping, subscriber based shaping. We provide the CDR collection, which is used for billing per flow. So all those things are all built using open source. Lastly, one of the things that where I told, we are working with couple partners. Again, this also is being built using open source. It's called the fronthaul gateway. It has a radio component for 5G as well as the networking component. The networking component is using this part. For the radio component, we are working with the radio stack, like the DU stack, or the MAC processing for the ORAN 7.2 or 7.2x split for the high MAC, high-fi processing. For that would be done as a radio, maybe a DSP or a FPGA would be used to do most of the processing. And eCPRI or CPRI would come, and then on the other side it will be Ethernet, either ROE or eCPRI, which will go to the DU or the BBU. Our model, I'm sorry, I'm going little fast now because I think we are almost out of time. It's a zero capex model, open source hardware with open open source software with open hardware, collaborative development. So with the customer, because the open source is available, they can contribute. They can also be part of the open source community. They can be part of the roadmap definition of the open source. So that's why it's all collaborative. Everybody can review the code. It's not binary whether there is a security backdoor entry. Everybody can look into that. Thousands of people review the code. Then our solution is customizable for the operator, and we have a subscription model, no capex. So that's how I think is the right approach to enable operators to really move to vendor agnostic solution from being vendor control, which vendor agnostic, which will enable for faster innovation, collaboration, and as we go ahead, will help you to actually reduce the cost, especially the OpEx cost. So it's very important to actually move towards such model. Some differentiation compared to traditional OEMs, and Then the second, like as I was telling, there are three generation: the traditional generation, then the current generation where you have disaggregated hardware, but the software is still binary. We have a lot of computers here, but again, there the software is proprietary, binary. You have no control. Again, the same vendor control stuff would come, because ultimately software is what matters. If that is still binary, so it's not really vendor agnostic, you're still dependent. So it has to go to open source. Software should be given to the should be accessible by the service provider. um, yeah, so I'll not but spend much time, but except that again, we are an annual subscription based model. Zero capex is what we are looking at, but we are flexible to work with how the customer looks into. And we come integrated with the hardware, like in case you need our choice of hardware, but even the operators can choose their own hardware and purchase it separately, and we can integrate our network operating system or our NOS onto that, be it for the DC, the routing kind of solution, or the DPI or UPF, or like the IoT kind of solution. Yeah, with this I would like to end. Thanks for your time, and happy to answer any queries if you guys have. And I'm reachable at abhijit@niralnetworks.com, or you can also visit our website www.niralnetworks.com. We can get in touch separately too. And thanks to OSI, Open Source Foundation, Open Source for You, to give us the give me the opportunity to present about Niral. And hopefully it was a useful session for the viewers. Hopefully you learned something. My takeaway from this is that open source is no more for trials or demo. It is real. It is getting career grade. You guys need to figure out building products. There are products which can be built out of open source, real solutions, real network infrastructure, real, not only network, I mean, think about any financial infrastructure, or like the DevOps infrastructure. All this can be career grade, and in fact most of the operators are deploying such open solutions in the network, initially in a small scale, then they would be increasing, right? So that's the third generation which I'm looking at, and I would encourage all of you to really participate and build on top of open source. Thank you.